I'm İlker. I am a computer science student at Bilkent University. Today, I will conduct an experiment for my Physics 102 final project. So, the purpose of this experiment is to study and measure the capacitance of a parallel plate capacitor in different conditions. The experiment will demonstrate that the capacitance of a parallel plate capacitor is proportional to the area of the plates and inversely proportional to the distance between them. The experiment includes two parts. In the first part, the distance between the plates will be constant while the area of the plates change. Using the plates with different areas, the capacitance will be measured. Then, the data will be recorded to a table and capacitance area graph will be drawn. In the second part, the distance between the plates will change instead of the areas. The same process will be repeated and the table and graph will be drawn. At the end, the actual values of the capacitance will be calculated. Using these calculated values and the measured values, the error percentage will be calculated for both parts. A power source, a multimeter, plates, a ruler, and wires will be used in this experiment. A capacitor is simply a circuit component that is able to store electrical charge. The capacitance of a capacitor is the ratio of the amount of stored charge to electrical potential difference. This is the formula to calculate the capacitance. The capacitance of a parallel plate capacitor is proportional to the area of the plates. It increases when the area increases. The capacitance is inversely proportional to the distance between the plates. It decreases as the distance increases. This is the data table of the first part of the experiment. For the first row of the table, we measured the capacitance as 0.33 picofards, and for the second row, we measured the capacitance as 1.1 picofards. And these are the calculated capacitance values and the error calculations. And this is the data table for part 2 of the experiment. Here we measured the capacitances as 0.33 picofards, 0.17 picofards, 0.11 picofards, 0.08 picofards, and 0.04 picofards. And here are the calculations for the capacitances for the part 2 of the experiment, along with the error calculations. This is the graph of the first part of the experiment, the capacitance area graph. We calculated its slope as 175. The slope is positive because the capacitance is proportional to the area of the plates. And this is the graph of the second part of the experiment, the capacitance distance graph. We calculated its slope as minus 3.6. The slope is negative because the capacitance is inversely proportional to the distance between the plates. So we are at the conclusion part of our experiment. To begin with, the experiment demonstrates that the capacitance is proportional to the area of the plates and inversely proportional to the distance between them. However, the error percentage is quite high. The main reason for this situation is the multimeter used in the experiment is problematic. Although this problem causes the values differ considerably from their actual values, it still measures the capacitance correct enough to fulfill the aim of the experiment, which is to demonstrate that the capacitance is proportional to the area of the plates and inversely proportional to the distance between them. If a better multimeter was used in the experiment, the error percentages were expected to be much less. Of course, there are other several reasons for these errors as well, some of which are parallax and uncertainty of the equipment. Another reason might be the fact that the electric constant of air is slightly higher than 1, while it is considered as 1 in the calculations. In spite of the errors, the experiment still shows the relationship of capacitance with area and distance correctly. As it can be seen in the capacitance area graph, the capacitance increases as the area of the plates increase, so its slope is positive. The reason why this graph is perfectly linear is the fact that only two different area values are used in the experiment. If there were more values, the graph will deflect a little bit and it would look like the capacitance distance graph, but with a positive slope. For the capacitance distance graph, it demonstrates that the capacitance is inversely proportional to distance, so the slope of the best fit line is negative. In conclusion, despite the largeness of the errors, the experiment shows that in a parallel plate capacitor, the capacitance will increase if the area is increased, and the capacitance will decrease if the distance is increased.